Imagine a frozen object the size of a city, drifting silently through the darkness of space. It has been frozen for billions of years. No sunlight, no heat, no change. Just an ancient ball of ice and dust traveling slowly through the outer solar system. Then something happens. Gravity begins pulling it inward. Slowly, it starts falling toward the most powerful object in our neighborhood, the sun. And the closer it gets, the stranger things become. The comet begins to glow. Gas erupts from its surface. A massive cloud forms around it. And suddenly, a spectacular tail stretches millions of kilometers through space. But what exactly is happening here? Why does a comet suddenly transform from a dark frozen rock into one of the most beautiful objects in the sky? Why does it grow a glowing tail? And why do some comets completely break apart when they get too close to the sun? To answer that, we need to start with something simple: what a comet actually is. When scientists describe a comet, they often call it a dirty snowball. That may sound simple, but it is surprisingly accurate. A comet is made from frozen materials like water ice, carbon dioxide ice, methane, and ammonia. Mixed into that ice are dust particles and rocky fragments left over from the early formation of the solar system. In other words, a comet is like a time capsule. The material inside it formed more than 4.5 billion years ago, when the planets themselves were still forming. Most comets live far from the sun in distant regions like the Kuiper Belt, or the enormous spherical cloud surrounding the solar system called the Oort cloud. Out there, temperatures are incredibly cold, sometimes minus 200 degrees Celsius or colder. At those temperatures, everything stays frozen solid. Nothing happens. A comet can drift quietly in the darkness for millions, even billions of years. But occasionally, gravity nudges one of these objects onto a path that brings it toward the inner solar system. And that is when the transformation begins. On Earth, when ice gets warm, something predictable happens. Ice melts, it becomes liquid water, and if you keep heating it, that water eventually evaporates into gas. So the normal sequence is solid, liquid, gas. But in space, something very different happens, because space is almost a perfect vacuum. There is almost no pressure, and when pressure disappears, the physics of phase changes as well. Instead of melting first, the ice inside a comet does something strange. It skips the liquid phase entirely. The ice transforms directly from solid into gas. This process is called sublimation. As sunlight strikes the surface of the comet, the frozen gases absorb energy. Their molecules begin moving faster. Eventually, they gain enough energy to break free from the solid structure. And instead of forming liquid water, they escape directly into space as gas. Suddenly, the comet is no longer quiet and frozen. Jets of gas begin erupting from its surface. These jets shoot out through tiny cracks and pores in the ice. And as the gas escapes, it drags tiny dust particles with it. This is the moment when a comet truly activates. And the next thing that forms is enormous. As gas and dust escape from the comet's surface, they begin spreading outward in every direction. Instead of drifting away immediately, much of this material surrounds the comet. The result is a massive cloud called the coma. Now here is something remarkable. The solid nucleus of a comet might only be 5 or 10 kilometers wide, but the coma surrounding it can grow thousands of kilometers across, sometimes even larger than an entire planet. This cloud is extremely thin, but it becomes visible for two important reasons. First, dust particles scatter sunlight. Each tiny grain reflects light like a microscopic mirror. When billions of these particles fill the space around the comet, the whole cloud begins to glow. Second, the gases inside the coma interact with ultraviolet radiation from the sun. That radiation excites the molecules, and when those molecules release that energy, they emit light. So the coma becomes a glowing envelope surrounding the comet. In other words, a dark, frozen object suddenly develops something like a temporary atmosphere. But once this cloud forms, the sun begins shaping it in an even more dramatic way, because now two powerful forces start acting on the gas and dust. Sunlight itself and the solar wind. Most people think a comet has a single tail. But in reality, comets usually develop two different tails, each created by a completely different physical force. The first is the dust tail. As gas escapes from the comet, it carries dust particles outward into space. Once those particles are free, sunlight begins pushing on them. Light may seem weightless, but photons actually carry momentum. When sunlight strikes a dust particle, it transfers a tiny push. This effect is called radiation pressure. Individually, each push is small, but over time, the constant stream of sunlight pushes dust particles away from the comet. Because the comet itself is moving through space, the dust forms a broad, curved tail trailing behind it. This is the bright tail people often see in photographs. But there is another tail that behaves very differently. This one is created by the solar wind. The sun constantly releases a stream of high-energy charged particles flowing outward through the solar system. When the gases escaping from the comet become exposed to solar radiation, they lose electrons and become ions, charged particles. And charged particles interact strongly with the solar wind. The solar wind grabs these ions and sweeps them directly away from the sun. This creates the ion tail. Unlike the dust tail, the ion tail is straight and narrow. It always points directly away from the sun, no matter which direction the comet is traveling. And sometimes this plasma tail stretches tens of millions of kilometers across space. A tiny object only a few kilometers wide suddenly creates structures larger than entire planets. But there is a limit to how much stress a comet can survive, because the same heat that creates these beautiful tails is slowly destroying the comet itself. A comet's nucleus is not solid like a rock. It is fragile, more like a loosely packed mixture of ice, dust, and rubble. As the comet approaches the sun, sublimation becomes stronger. Gas erupts more violently from the surface. Jets burst from cracks, and these jets push on the comet like tiny rocket engines. They spin it. They stress it. They tear at its fragile structure. At the same time, heat penetrates deeper into the nucleus. Internal pressure builds. Cracks grow larger. Eventually, pieces begin breaking away. Sometimes the comet simply fragments into multiple pieces. This happened dramatically with comet Shoemaker-Levy 9, which later collided with Jupiter. Other comets disintegrate entirely, leaving nothing but streams of dust along their orbit. When Earth later passes through those dust streams, those particles burn up in our atmosphere, creating meteor showers. So sometimes, the glowing streaks we see in the night sky are actually the remains of a comet that died long ago. A comet may look like a mysterious visitor from deep space, but its transformation near the sun follows simple physical laws: heat, light, gas, gravity. Small forces acting over time create enormous structural tails millions of kilometers long. And that idea that simple rules can produce extraordinary beauty is one of the deepest lessons in science. It is something physicists like Richard Feynman love to remind us. The universe is not complicated because it hides secrets. It is complicated because simple laws, acting everywhere, create astonishing results, and sometimes those results light up the sky.